term, the two majors, we're looking at evaporation. This is the second one, condensation. Basically, you can say that these two are opposites. You take evaporation, you take water in the liquid form, and you transfer it into water in the gas form. Condensation is just the opposite, where you take water that is in the gaseous form and convert that into water to the liquid form. Condensation process in which gaseous water, the water vapor, is changed into a liquid form, which will be regular water. Anybody think they can give a good example of condensation? Or some time when they experienced what they thought was condensation? Curtis?
Like dew, in the morning.
Okay, dew on the grass. If you happen to get up nice and early, and it depends on the environmental situation, and take off your socks and shoes and go running barefoot through the grass in the morning, your feet might get wet. That's from dew or water that was out of the atmosphere that has collected on the grass. That's one example. Another example of condensation, I'm sure you've all experienced. Nathan?
When it's cold outside and you breathe on the window glass.
Okay, that's one. Cold outside, you go up to a window itself, you breathe on the window. You have, every time you exhale carbon dioxide, other gases, as well as water vapor. The water vapor in your breath hits the window, it cools and collects, and that's condensation. Another one. Right?
Like when you're cooking and the steam from the pan hits the lid.
Okay, that's one. If you're boiling something, cooking something, you take the lid and lift it up, and there's water collected. Take the lid, sit it on the stove, and then you have water that runs everywhere. Another really good example. You've all experienced. A picture from the book. Exactly. You take a cold glass of water, take it out, set it on a table or whatever, especially sometimes you come back, and then there's moisture all around the outside of it. I did this, we'll do it here just a little bit. One time I was talking about condensation in 4th grade, and I asked them, I told them, here's a glass, it's got water on the outside. I want you to tell me how this got here. You come up with how it is. And I said, you can only tell me, or you can only ask me questions that end in yes and no. And we sat there for 45 minutes, they asked me questions, Mr. Schnorr, yep. And I said, no. When they finally came up with the reason why condensation takes place. Now, where we know that condensation is water collecting on the outside of the cup. What I want to know is why. This is my question that posed to you. TJ, what do you think? If I take this Pepsi can, and right now I can pick it up and feel it, and it's got water on the outside of it. Why does it have water on the outside of the Pepsi can?
It's like cooler on the inside and warmer on the outside. So it's like evaporating.
Like evaporating? Okay, he's got some good points, and right off the bat, he's got pretty close. What do we know about two things? First of all, this Pepsi, is it warm or cold? It's cold. When you take, example, condensation, and you take water from a gas form, or like water vapor, and you try to turn that into water in liquid form, what do you have to do to that water, or that water vapor? You get to go from a gas to a liquid. It's the same thing you have to do to make it go from a liquid to a solid. Curtis?
You have to take the heat out of it to make it go from a gas form to a liquid form.
Okay, what's another way to say take the heat out of it? Cool it. If you cool water vapor, it turns into liquid. If you cool liquid, it turns into solid. Why do you think that the water vapor in the air is collecting on the outside of this Pepsi? Because it's cooler. So what's that do to the air around the Pepsi can? It cools it, and the water vapor in that air around the Pepsi can cools and turns to water. Collects on the outside of the Pepsi. That's condensation. And there are 100 examples. Everybody got this? We'll talk more about this a little bit. Next one. Saturated. Term used to describe the air when it is at the limit for the amount of water vapor that it can hold. This one, you can use saturated to describe a great deal of them. The one we're looking at is the atmosphere. The air in the atmosphere will only hold a certain amount of water vapor. When it reaches the point where it loses its ability to hold water vapor, what does it do? Yeah? It rains. Or you get a rapid temperature change, and suddenly a cloud can't hold as much water vapor as it used to, and then it rains. Another thing to use describe saturated. Nice dirty sponge here. Is this sponge saturated? Caleb? air can really hold. For example, if I have this is my box of air. Okay? This box of air is 80 degrees. And I have a little chart that some weather guy has told me that in this chart, or on this chart, it says that if I have this box of air at 80 degrees, it will hold 10 milliliters of water. At 80 degrees, this box will hold 10 milliliters of water. Now, and I measure and I find out that there are only 5 milliliters of water in this box of air that I've got. What? That next to the relative humidity. What's that? Why is it 50? Okay. It can hold 10 milliliters total. And currently the air is holding 5 milliliters total. That's half. 1/2, 50%. That's relative humidity. Weatherman has invented little devices to determine relative humidity. They know, depending on what the temperature is, how much air or how much water vapor the air can hold, how much is actually in it, and that's relative humidity. The device they use is called a psychrometer. Now, this is basically a simple version of a psychrometer. This is the one I whipped up yesterday. Very simple. All it's got 2 thermometers. These thermometers are exactly the same. They both read Celsius. I just took a mounted them to a piece of, like a file folder. 2 pieces of foam, cut little notches in it, ran them across there. What's the main difference between the two, though, is this. On one part of the thermometer, I took a bunch of this filter wool, or cotton basically, and wrapped it around there, and then connected it with some rubber bands. These are called bulbs of the thermometer, the silver parts down here on the bottom. What they do to measure relative humidity is they take these two, and they take this bulb here, and they get it wet. This is the wet bulb, this is the dry bulb, this one stays dry. They read the two, they will come up with different temperature readings. Then you do a little formula, which is really easy, I'll show you just a bit. You come up with the relative humidity, or actually what the humidity is in the air compared to how much you can actually hold. That's the psychrometer. We'll look at that a little more in a bit. Next one, absolute humidity. This is pretty simple. Basically, it's to measure the amount of water vapor that's in the air at a certain time. Or I guess that's up there. Measure the amount of water vapor that the air contains at any given time and place. So that's a measure of how much moisture is in the air. This is not concerned with temperature. This is not concerned with how much water or water vapor that air can hold at that time. But just at that point, how much moisture or water vapor is currently trapped in the atmosphere. That's absolute humidity. Difference between absolute and relative humidity. To determine relative humidity, you have to know the temperature. You have to know how much moisture can actually be held in that air at that point. And then you have to have a psychrometer or something to tell what the current rate of evaporation is, what the temperature, and what the regular temperature is. Got this? Questions so far that you have? No? We got just one or two more. Here. Psychrometer. That's what I just showed you. Tool used to measure relative humidity. It's composed of a wet and a dry bulb thermometer. Not very difficult to make a wet bulb thermometer. Wrap a piece of cotton around it, give it some water, press those change the old wet bulb. We actually have 2 more vocabulary. Next one, dew point. This is the one that Curtis was talking about when he gave us an example of condensation. You're looking at the temperature at which condensation occurs. If the dew point is below 0 degrees Celsius, then you have frost. I was news last night. They said the low last night was supposed to be like 60 or 66 degrees, and the dew point was 48. That meant that if it got down to 48 degrees, or 47 degrees or whatever last night, and I went